Alright, in this video I'm going to talk about positive rational exponents. So before we talk about positive rational exponents, let's just review what the word rational means. So what is a rational exponent? Well, remember, a rational number is a number that can be written as a fraction. So a rational number is a number that can be written as a fraction. So examples of rational numbers are like 1/2. The number 2 is a rational number because it can be written as, 2/1 or 4/2 and so on. So the number 2 is a rational number. Any whole number is a rational number. The number 1, the number 0, because that can be written as a fraction, 0/1 or 0/2, so on. A number like 3/4, 1/8, and so on. So a rational number, it could even be like 679 over 281. And I have no idea what that is, but I know I can write it as a fraction because I just did. So it's a rational number. So a rational number is any number that can be written as a fraction. We also think about it as a rational number if it has a decimal, the decimal ends at some point. So, for example, and the exception to that is if it doesn't end, then it repeats forever. It repeats in the same pattern. So, for example, 1/4 can be written as 0.25, and that's it. The decimal ends there. Another example, let's see, 1/5 can be written as 0.2 exactly. 1/3 actually does go on forever. It's 0.33 repeating. And so that doesn't ever end, but it has a repeating pattern. So it's predictable to know what the next decimal is in the number. So a rational number, if you want to think about it as the decimal, either the decimal ends or the decimal repeats if it doesn't end. So if a number goes on forever and it doesn't have any sort of predictable pattern in the decimal numbers, then it's an irrational number. So that was just a quick review of rational numbers. So when we talk about rational exponents, we're talking about exponents of these kinds of numbers. So like, let's say we have the exponent, let's say we have x to the 1/2 power. That 1/2 would be a rational exponent. We can also have x to the 3/4. That would be a rational exponent. It also doesn't have to be an exponent on a variable. It can be just an exponent on a regular number, like 2. We could have 2 to the 3/2 power. The 3/2 would be a rational exponent. So you guys get the idea here. We're pretty much just looking at exponents that are fractions. And remember, rational doesn't have to mean it's a fraction, but we're specifically looking at the fraction exponents here. So let's look at some examples of how we would think about rational exponents. So let's remind ourselves just how exponents work in general first. So 2 squared, that's an exponent that we understand already, that we already know how to compute. So 2 squared just means 2 multiplied by itself 2 times. So 2 times 2, and that's 4. If we had like 3 squared, that would just be 3 multiplied by itself 2 times. So 3 times 3, and that's 9. 2 to the 3rd power would just be 2 multiplied by itself 3 times. So 2 times 2 times 2, and that would be 8. So you guys get the idea. So if we have, like, for example, let's have 3 to the 1/2 power. So what the heck does a 1/2 power mean? Well, if we think about it in terms of how we were thinking about these up here, this was like 2 squared was 2 multiplied by itself twice. So 3 to the 1/2 would be 3 multiplied by itself half a time. So what would that mean? Well, that means that we're finding something that would multiply by itself to get 3. So in other words, it's the square root of 3. If we multiply the square root of 3 by itself 2 times, then we get 3. So that's the idea of the fraction exponents here. If we had 3 to the 1/3, it would be something that multiplies by itself 3 times to get 3. So it would be the cube root of 3. So we can multiply this cube root of 3 by itself 3 times and we would get 3. So let's look at, what if we had like 4 to the 1/2. Why don't you pause for a second and see if you can figure out what that would be. So this should be the square root of 4, which would actually be 2. Let's try another one. So let's do 5 to the 1/4. Why don't you pause the video for a second and see if you can figure out what that would be. So this would be the 4th root of 5. And we can't simplify that, so we would just leave it like that. Now what about 2 to the 3/2? Why don't you pause the video and see if you can figure out what that would be. So there's a couple ways we can think about this. I like to think about it as we can split this up into, this would be the same as 2 to the 1/2 to the 3rd power. And remember, if we take something to an exponent to another exponent, we just multiply the exponents together. So this would be the same thing as 3 to the 3/2 because 3 times 1/2 is 3/2. And actually, we could also write it as 2 cubed to the 1/2 for the same reason, because 3 times 1/2 is the same as 1/2 times 3. So all of these are equal. So this one, we could write it as the square root of 2 to the 3rd power. This one, we could write it as 2 to the 3rd power and then square root that whole thing. And this would actually be equal to the square root of 8. All right, let's try another one like that. Let's do 5 to the 2/5 power. You can pause the video for a second if you want to see if you can figure that out yourself. But basically this is going to be 5 squared to the 1/5 power, or 5 to the 1/5 squared. So it would be the 5th root of 25, or the 5th root of 5 all squared. So either of those would work. I personally like this form better. I feel like it just looks nicer, but this would also work. So these are the same. These are equal. So either of those would be acceptable. Let's do one more. Let's try 10 to the 3/2 power. This is going to be, I'm going to skip some steps here. It's going to be the square root of 10 cubed. Or you can write it like this, the square root of 10 cubed. Those mean the same thing because of our exponent rules. But this could also be written as the square root of 1,000 because that's 10 cubed. So all of these are correct answers to this. So hopefully that makes some sense, the way we deal with these fractions as exponents. In the next video, I'll talk about how to deal with negative exponents that are fractions as well. So I'll see you in that video.